Welcome to this festival for love of the world. Welcome. This festival is presented to you by Studium Generale of TU Delft in cooperation with this beautiful theater, De Veste. So, we invite you to join us to look for different and new stories about our world. Let me have a look how you are sitting. Can I have a little bit of light in the audience? Because I want to have a look if you're sitting comfortable. So, if you're sitting comfortable, I'm joining you. And let's have a look up to the roof of this theater. Are you looking up? Well, imagine that this roof would not be here and you will be looking at the stars. Can you imagine that? Let's have a look if you're looking. Yes. So, do you like looking at the stars? Who of you does that, by the way? Yes. Quite some people. I think almost everybody looks to the stars now and then. So, and when you look at the stars, do you feel this connection with the stars? Or this connection maybe with the whole universe? Who does that? Who feels this? Yes. Not everybody, but I think half of you will feel this connection with the universe. Well, according to our first keynote speaker of this festival, the universe and everything in it is connected. And he calls this the One. We are one. His latest book is also called The One, in which he explores our relation with the cosmos. And I think after his talk you feel more connected. Maybe you also feel one. He is a professor at the TU Dortmund in Germany, and he researches particle physics, cosmology, and the structure of space and time. Please give it up for Heinrich Päs.
Thank you.
Welcome, Heinrich.
Thank you.
The stage is yours.
Okay, thank you. Yeah, so this is my new story about the world, the One, how an ancient idea holds the future of physics. About 15 years ago, I was standing alone, waiting in a deserted, pitch-dark alley in a tiny village in the middle of the Atacama Desert in Chile. And above me, countless stars were sparkling. They provided such a magnificent view that it was hard for me to look away, keeping an eye out for the tour guide's truck that was to pick me up for a trip up to the Altiplano, the high plains, to watch some flamingos stalk a secluded salt flat in the first light of the rising sun. I guess most of us know these magical moments when we look at the stars, at the ocean, or just walk through a forest in fall. Now, I'm a theoretical physicist, but sometimes I have feelings too. So what I feel in such magical moments is that I'm totally insignificant, but at the same time, strangely at home in the universe. Now, what does it mean to be at home in the universe? For a physicist, there are 100 billion stars in the Milky Way, our home galaxy, which is just one among a trillion galaxies in the universe. Apart from the stars, there's 10 times more ordinary non-luminous matter, for example, in gas clouds billowing around in interstellar space. And then, in addition to ordinary matter, there's 5 times more dark matter. The puzzling new particles we couldn't identify yet. We just know from their gravitational pull. And then, what's more, there's 3 times more dark energy, the enigmatic fuel that drives the accelerated expansion of the universe. And maybe there are even other universes. Maybe our universe is not the only universe. There might be parallel universes. On the other hand, literally, universe means turned into one. All-encompassing, turned into one. So how can we make sense of that? How can this unfathomable vastness possibly be one? Well, this brings us back to an ancient idea, that the ultimate reality might be an inseparable whole. 25 centuries ago, Heraclitus, a Greek philosopher, wrote, "From all things one, and from one all things." And similar ideas are known from Asian philosophies and religions, Taoism, Hinduism, Buddhism, and many other belief systems and philosophies. So what my point here is, my claim, is that physics provides us with exactly this notion once we adopt a quantum perspective onto the universe. So what do I mean by a quantum perspective? I will explain that, of course. I mean, I could show a lot of equations, a lot of experimental data to make this case, but I decided that I want to concentrate on the basic ideas to give you a feeling what this means. So I start with physics, but in a non-technical sense. I will explain how all is one if we adopt a new quantum perspective onto the universe. And then I briefly want to sketch what this might mean for us, how we are related to the one and love of the world, which brings us to Plato, Spinoza, and Goethe, and also sketch briefly why does it matter. In fact, there's a crisis in fundamental physics. These new ideas, this new perspective, might help to resolve it. I believe it might help. And maybe it provides us also a blueprint to tackle crisis in the world. So we start with 5 brief lessons on quantum mechanics. This is about particles and waves, and that a particle in some sense is a wave, and a wave in some sense acts as a particle. Then we will learn that the wave has no place, which brings us to superposition, which is the coexistence of different realities in quantum mechanics. Then we will overlap waves, which corresponds to the quantum phenomenon of entanglement, which describes what happens when we put quantum objects together to build larger objects. And then we apply it to the universe, and we'll realize that in an entangled universe, all is one. And finally, we address the question, if all is one, why do we experience the world as plurality? Why do we see many things? Which is nicely illustrated by the allegory of Plato's cave. Okay, quantum mechanics grew out of an old argument. For centuries, physicists were arguing whether matter is described by particles or waves, and whether light is described by particles and waves. And then, in the early 20th century, people realized, well, both is correct. Waves, like light, absorb or emit energy in indivisible portions, or quanta. And on the other hand, the propagation of particles, such as an electron, is described in terms of waves. Louis de Broglie in 1924 called this wave-particle duality. So matter has a dual nature. But what does it mean if matter are described by waves? So here you see a wave, and you might think of this as many waves. One wave here, one wave here, one wave here. That's not true. It's just one wave. It's one wave with many wave crests. So all of this is one wave, and obviously we can't say where this wave is. Is it here? Is it here? Is it here? Is it here? So if a particle is described by such a wave, it doesn't have a specific location. A particle described by a wave can exist in several places at once. Now, what's more, this isn't restricted to particles. This applies to every object and every property. So Erwin Schrödinger, one of the quantum pioneers, in 1935 came up with a crazy example called Schrödinger's cat, which is a cat which is in the superposition of being dead and alive. Yeah, in quantum mechanics, this isn't just true for particles and their locations, but for any object and any of its properties. One may think of a cat being dead and alive at the same time. So if this isn't weird enough, we can start to build larger quantum objects out of smaller quantum objects, which brings us to entanglement. I took this picture a few days ago when I went with my 4-year-old son to a pond next to our house, and we were throwing stones into the water. What you see here is we threw two stones, and each of them produced a wave, and these waves overlap. Now, what does it mean that waves overlap? They just get summed up. If I have such a wave and such a wave, I sum them up, I get this wave here. The point is, the other way around, it's not so easy. If I just get this result here, I don't know whether it was produced by these two waves or some other combination. For example, look at a perfectly flat surface. This may be produced by this wave here, and it's negative. They cancel each other, so it ends up perfectly flat. Or just two flat surfaces. Or this wave here, and it's negative. So if we just see that, we can't say what it was made of. Now, if we describe matter by waves, this is true for matter. So we can't say what matter is made of. If we go back to our example of two cats, one is alive, one is dead. This may be the first cat is alive and the second is dead, or the other way around, the second is dead and the second is alive and the first is dead, or both cats are half alive and half dead, or the first cat is 30% alive and the second cat is 70% alive. So this is very weird, but that's quantum mechanics. In an entangled quantum state, constituents can be so completely merged that it is impossible to say anything about the constituents anymore. This is a quote by Lenny Susskind, a prominent string theorist. It would make no sense for a mechanic to say, I know everything about your car. I know everything about your car, but unfortunately, I can't tell you anything about any of its parts. I don't know anything about the wheels. I don't know anything about the brakes. I don't know anything about the motor. I can't say anything about that, but I know everything about your car. But in quantum mechanics, one can know everything about a system and nothing about its individual parts. Entangled quantum objects form an inseparable whole. Now, in quantum mechanics, a system is completely described by its properties. A system essentially is its properties. So if we don't know anything about the properties, the quantum object doesn't exist at all. Quantum entanglement was the topic of the 2022 Physics Nobel Prize. The experiment these gentlemen here, the prize winners, performed, they didn't demonstrate that entanglement is true. They also demonstrated that entangled quantum systems can be big. Usually people think of quantum mechanics as something which applies only to small, tiny particles. It's not true. This gentleman here to the right, Anton Zeilinger, he performed an experiment where they had entangled light spread out over 143 kilometers between the Canary Islands of Tenerife and La Palma. So quantum systems can be big, and the constituents of entangled quantum states are totally unknown. We can't even say that they exist. If we apply that to the universe, that means in an entangled universe, all that is the universe itself. In an entangled universe, all is one. This is a quote by David Bohm, a quantum pioneer here. The entire universe is basically a single indivisible unit. What's more, if everything is everywhere, there exists no matter in the traditional sense. And if there's only one thing, the universe itself, that is everywhere, there exists no space in the traditional sense. Space as a meaning of this is relative to that, left of that, right of that, or something like that. Doesn't make sense anymore. And if there's only one thing, nothing can change, so there exists no time. So we end up with a universe in which all is one, and there's no matter, no space, and no time. Now, obviously, we have the impression that there are things, that there's space, time, and matter, that we exist, right? That this room exists, that this screen exists. How can that be? This is due to a phenomenon known as decoherence. So if all is one, there's no space, time, and matter, why do we experience the world as a plurality? The point is, we observe and experience the world from a limited perspective. A very nice allegory for this is Plato's allegory of the cave, where he compared us to prisoners who are chained inside a cave, and all they can see are the shadows on the wall. So they never experience anything else, so they believe these shadows are reality. But of course, the reality is outside. The reality are these things which are carried by. Nevertheless, for the prisoners, the reality seemed to be the shadows. And in a similar way, we observe and experience the world from a limited perspective. We can't know the entire universe. We just know a little bit part of it. And this leads to the illusion of matter, space, and time. Right? Look at this picture here. If I take parts away of this single one, it looks like many things. Or even closer to Plato's allegory of the cave, we can think of the universe as a projection. Here in the projector, we have a light bulb and we have a film roll. What the film roll is taking information away from the light bulb, absorbing some light from the light bulb. And this produces these pictures and produces a story, produces the illusion of space, time, and matter on the screen. But what's real here is the light bulb. Okay. So this is a new quantum perspective onto the universe. The question is, how does it relate to us and why does it matter? What's interesting is if you compare these ideas to the experience of subjects in altered states of consciousness, for example, people under the influence of psychedelic drugs, meditation, extreme situations, mystical visions, such things. In a quantum universe, we have it that all is one, that time and space emerge perspectively from our perspective. Via decoherence, which means there is limited information about the rest of the universe. If people are in a psychedelic state, this is very similar. They experience a dissolution of the mental self, a non-local experience, a dissolution of subjective time experience, and this might happen due to an inhibition of information filtering in the brain. So the filtering of information doesn't work properly anymore, so we get more information, and this leads to the dissolution of locality and of time. This is a quote from Aldous Huxley from a book, The Doors of Perception, which is named after a quote by William Blake: "If the doors of perception would be cleansed, we would see everything as it is." Huxley writes, in the final stage of egolessness, there's an obscure knowledge that all is in all, that all is actually each. So is that related to physics? We don't know. We can't say. Most physicists will say, of course not. I think that's an interesting question. We should look into it. But we don't know yet. Well, what we do know is that this reminds of the philosophy of Neoplatonism. Neoplatonism is a philosophical tradition which started before Christ, after Plato, and went on until today, essentially. Neoplatonism claims that all is one, and the one is identified with truth, and the part that we experience is representative of the whole, of the truth. And love and beauty help us to ascend to the truth. This can be thought of as escaping Plato's cave. One of the prisoners escapes his chains or her chains and climbs up to the entrance of the cave and sees the world as it is, sees the sun, sees reality. This is a quote by John Scotus Eriugena, a philosopher in medieval Francia in the 9th century. The beauty of the whole established universe consists of a marvelous harmony of like and unlike, in which the diverse and various species and substances, what he calls natura creata, the created nature, are composed into an ineffable unity, what he calls natura creans, the creating nature. And the pacific embrace of universal love gathers all things together into the indivisible unity. Now this reminds of a local hero here, Baruch de Spinoza. This statue here just stands a few miles from here in Den Haag. He spoke of intellectual love, or God, also known as nature. And just like Eriugena, he compared two kinds of nature. The naturing nature, natura naturans, which he identified with God, and the natured nature, the creations. Friedrich Schleiermacher said about Spinoza, for the wholly excommunicated Spinoza, the universe was his only and lasting love. Spinoza again inspired Goethe, who wrote a poem, Wiederfinden, reunited in English, where he described how in love we get reunited with a fragmented world. And he also inspired Einstein, who famously said, I believe in Spinoza's God. So why does it matter? Why does all this matter? In fact, right now we have a crisis in physics, in fundamental physics. This is a quote by Jan Judice, who is the head of CERN's theoretical physics department. CERN is hosting the largest particle accelerator in Geneva from 2017. So he wrote, we are now witnessing the beginning of the phase of crisis. We are confronted with the need to reconsider the guiding principles that have been used for decades to address the most fundamental questions about the physical world. So what's the trouble? What's the problem? We don't understand how particles get their masses. And we don't understand where the accelerated expansion of the universe comes from. And we don't know where gravity comes from. Or more concretely, what we don't understand is why the mass of the Higgs boson, which is the particle that corresponds to the field that gives masses to all other particles, is so small, so much smaller than the energy scale of quantum gravity. We also don't understand why the dark energy density, the energy density of the fuel that drives the accelerated expansion of the universe, is so much smaller than the energy scale of quantum gravity. And this is not a factor 10 or 20 or 100 smaller. This is a factor of 10 to the 120. A 10 with 120 zeros too small compared with our expectations, with our calculations. And finally, we don't know how to obtain a quantum theory of gravity and space-time. Now, these problems make our best theories, the standard models of particle physics and cosmology, appear fine-tuned as a pencil balancing on its tip. The question is, how can we revise the guidelines, the guiding principles of how we try to describe nature so far? What are these guiding principles? Well, the common paradigm in particle physics is the paradigm of reductionism. This means matter can be decomposed. Matter is made of atoms. Atoms consist of electrons in the atomic shell and protons and neutrons in the atomic nucleus. and protons and neutrons are built from quarks. And electrons and quarks, and in addition neutrinos, another type of particle, they are the fundamental building blocks where everything in the universe is made of, apart maybe from dark matter. So the question is, this was very successful so far, but is it really right? Will it be successful also in the future? And if we realize that the entire universe actually is a quantum object, an entangled quantum object, which has no defined parts, where all is one, then maybe it makes sense to adopt a more holistic approach. This is a cover of the New Scientist magazine, featuring an article I wrote last year in July, where I describe how in the face of new evidence, physicists are starting to view the cosmos not made up of disparate layers, but as a quantum whole linked by entanglement. Also about quantum gravity, about finding a quantum theory of space-time. Leading string theorists believe now that space and time may emerge from entanglement, from the wholeness of the universe. Space emerges from quanta, and the nearness in space is described by the entanglement, by the correlations of things that can be deduced to the fact that they are part of one whole. So in real life, we also have crises. Not everything is physics. We have this daunting climate crisis we are facing. We have political extremism, pandemics, the war in Gaza, migration, disinformation, social polarization, the war in Ukraine, religious fundamentalism, and so on. We have a lot of crises, and of course, I don't know how we can solve them, but maybe a change in perspective can help. Maybe if we realize that we are not separate individual beings, but that we are all part of a bigger universe, that we belong together, that may help. Okay, summary. Quantum superposition. The fact that a wave has no place allows competing realities to exist. Particles can exist in different places. Quantum entanglement describes what happens if we combine several quantum objects to larger objects, and it merges the quantum objects into an inseparable whole. If we apply that to the universe, we arrive at a quantum universe where all is one. Matter, space, and time may be illusions. And then we can explain why a decoherence from our perspective, our limited perspective, onto this one, onto this quantum universe, why this one looks like a plurality of things from the perspective of a local observer like us. So this triggers questions, of course. If all is one, who are we? Who are you? How separate are we from the world? What does it mean to love the world? And can new ideas in physics about how the universe works change our perspective on everyday problems and crises? I don't know the answer. I leave that to you as an inspiration. Thank you. I don't know. Do we have time for questions or discussions or something? Are there questions? Yes, please. Oh, I didn't understand. Can you talk a little louder? Oh, good question. It's always hard to say that in retrospect. I mean, the question is whether I had an aha moment where I realized this, or whether it was more like a slow process. I don't know. I mean, there were several things, I think. I talked a lot with one of the quantum pioneers who died 5 years ago Heinrich Päs, the man who discovered this process of decoherence. And this changed my perspective onto quantum mechanics. And then as a postdoc, I lived for 2 years on Hawaii, which is, as you know, a tiny island in the middle of a vast Pacific Ocean. And this also changed my perspective a little bit on how nature works, and that we depend on our surroundings, and that we are not as individual and separate from the world as we are. So these were two things which drove my my understanding in this direction. But I don't know, there might be others, and yeah. So I think it's something in between a aha moment and a slow process. Okay, maybe in the last line over there, yeah. Something is flying. Oh, good.
So, based on my understanding, the whole presentation is taking for granted that we do live in a quantum universe, right? But is it not possible that there are just laws of physics that we don't understand, rather than there being a coherent whole? It's just, for example, string theory is something that tries to look further than quantum theory, right? But your whole presentation is based on the assumption that the quantum universe is a correct explanation, right?
Well, yes. I mean, of course, science is not done yet. We don't have the final theory about the universe. And there might be surprises. But I think most people would be very surprised if quantum mechanics wouldn't be a part of the final answer.
Can I add a corollary?
So, I mean, of course, it could be that there are some mechanisms which break quantum mechanics down, for example, for macroscopic large objects. But no such mechanism has been found yet, and they are probably, or as far as we can see, they are not compatible with relativity. Another idea is that quantum mechanics actually isn't a theory about nature, but it's just a theory about knowledge, about our knowledge of the world. I cannot say that this is wrong. I cannot prove that this is wrong. But to me, this would mean that people claim that what's on the screen is reality and what's outside here isn't. And this makes no sense to me. But you are right, there are some other ideas about the world. But I think most physicists will agree that quantum mechanics will be a part of the final answer of the theory about the universe. And if we take quantum mechanics serious as a theory about nature and not just about knowledge, I think this follows straightforwardly.
Sorry, I have a more technical question for Adap. That you talk about decoherent theory, and that was one of the major rules for the idea of all is one. But I also have studied a bit about ion selection proposed by Wojciech Zurich, where he talks about the idea of quantum Darwinism, and I feel like it's a very promising theory to explain this whole idea. But I want to hear, do you have any ideas on
Yes,
theory?
I agree. It's a promising idea, but it doesn't address the whole question. Since in these approaches like ion selection, you always presuppose a classical environment, or you presuppose what the environment is. And then from this presupposition, you make, you conclude something about the quantum system. And this makes sense as long as you assume first that the environment is classical or has some classical properties. But if you don't do that, if you start from scratch and say everything is quantum mechanical, then this doesn't follow. And so I think this is a good approach for practical purposes, but it's not the fundamental answer if you talk about fundamental things.
Yes, I also have a question.
Can I ask one question? Small question?
Yes. Do you also work with biologists? Because if you zoom out, like physicians do you also work with biologists to zoom in? Because there's also a lot of knowledge from the nature itself. And can that give answers in how the symbiosis in nature itself works, and to look like an orchidee or a lichen? There are so many maybe questions right under your feet.
Yeah.
And maybe answers.
Is
Do you
it
work
easy
together
to
with
answer
other
questions?
disciplines?
It's a good question, and I agree. I mean, there might be interesting things to be learned from such systems, and quantum phenomena may play a role in biological systems, but I'm not an expert on biological systems. The problem with biological systems, of course, is also that they are much more complicated than just particles or inanimate objects. So in some sense they are more available, but in some sense they are also more complicated to study. And it's not my expertise. But I think the next
keynote speaker, yes, that's actually a brilliant bridge. I hope to see you back in at 5 o'clock, because our next keynote speaker is a biologist. So I hope you will be there. My last question for you: who feels more connected with the universe right now? Heinrich, are you surprised? Your talk has had an effect.
Okay.
So this was really positive. Thank you so much, Heinrich, for your talk. And thank you for being here. See you at the next keynote.